And now I do have what? Two network IT. The first one and the second one. Correct? And that's the way I see it. Correct or not? Correct. So when I see 0 or 1, meaning what? When I go over here, I'll write down the 0 or 1. So I have the first one is going to be 0, so I'll go down here and start writing down what? 0. Correct? And write down what here? 1. And what the rest? The rest is going to be what? The host. Which is going to be what?
0.
Correct?
Yes.
Right or not?
Yes.
Now, when I said actually I'm going to actually add this network portion to the rest of the network, so it's going to count from where?
Left.
From the left to the right. It has to be ones, right? It has to be 1, correct? So the network here is going to have what? A newer what? It has to be 1. Because that's actually telling me this bit is belong to the network portion. It has to be 1. And everything is to belong to what? To the host, correct? So I'll have here 1, 2, 3. What's your question?
Yes. I thought we just copied the original subnet in the original, the old subnet, the old
This one here.
Yes.
Yes.
For the first network.
That's the old one, correct?
Uh-huh.
But that's actually belong to what we call the class fault C. Because it's a class fault C, right? Here, the operation here, we do it what we call classless. We already what? Because that's already given, had been locked, so I already copied here. You see that?
Okay.
So I'm taking the last portion where I can change it. So I took the N here, and I have either 0 and 1, and it's added to your network IT. So I have the 0 here, and you have the 1 here.
Okay.
And each one of them is what? Is allow me to have how many PCs? 126. 126 is plenty? Yes, it's enough. So the 126 should be enough for 100. Correct or not? Right?
Correct.
What about the other network, 60 and 60?
So you would break off.
I gotta pick off another one. Either way, I can choose that or that. So which one I can use? Let's use that as an example, right? So now I do have. Now I need to deal that as a newer network given. So take that as an example. Looks like it's like an old one, but that's a newer exercise. So now I need to to break it down to what? To other networks. So what I'll do here, I need to write the whole things in decimal, right? Let's convert everything to the decimal. So the first one is going to be what? 192, 168.1 dot what? 128. Very good. So I can write that in 128. And here down here, what's going to be? 255, 255, 255 is what? 128. Very good. 128. Also in 128, I do have actually what? The host portion and the network portion. Because this portion from here is belong, even the last digit bits here belong to the N. And the rest of that is what? Host. So that looks like the N here is already locked with that. You see that? Is already what? It's already locked. So let's open back again to have it in a decimal, in a binary form. So that's actually going to be what? This one here is going to be 1. Correct? This one I cannot really what? Change it because it's already locked. Correct? So now I do have actually what? The 7 bits. According to the math, 2 to the power 7 minus 2, which is 128 minus 2 equal 126, right? Now I need to have enough address from here to be enough for a 60. He wants me to do 60. The first network and the second network. So you remember this one here? If I have the host 6-bit, if I borrow actually what? 6 bits from here, what's going to be my math for the host? how many PCs I can assign from my IP address. Yes, for this network. So 2 to the power 6 minus 2, 64 minus 2 is going to be what? 62. So this one will work with here, right? Because 62 is what? Is greater than 60. As I said, it has to be almost equal or greater. It's much better to have a little bit greater, to have more spares. But anyway, we have it here as spares. So according to the math here, just write it down here for myself, is 2 to the power 6 minus 2 is equal 64, right? Minus 2 equal 62, which is enough for 2 networks. Meaning, I will take just 6 bits for the host, right? And I'll leave the what? The last one for what? For the network, right? Anyway, this one is already there with this one. This digit bits, right, is already included here. So it's part now for the new network. So I cannot change it, right? Now, by looking back again to the exercise, I have in 1 bit for network portion, and I have a 6 for what? For a host portion. How many network I can come out from that? 2. Why is 2? Because I have 1 digit bits. 2 to the power m, because m is what? Is 1, it's going to be equal to 2. So I can have it what? Either way, 0 or 1 now, which is very good. So now I can really draw it again. 2 network, I can come out from here. The first one and the second one. As I said, that's already locked, right? With this. So what you will do here, you're going to carry that 192, 168.1, and let's write it down in binary format. I have 1 here, right? And everything could be what? Zeros. It depends. We'll see what's going to happen. The same way with the other one. 192, 168.1.1. That's in binary, by the way. That's in binary. Okay? So now, also at the same time, I need what? To copy the subnet. So it's going to be what? 255, 255, 255, what? 1 in binary. Don't forget the one that's here, the one over there. It still belongs to this network, the old one, because the old one you have to copy it. You cannot change that. 1 in binary. Correct? Now, we mentioned before, if I do have that, in the last one, belong to the network portion, of course, has to be 1 here, right? I need to add another 1 over there. So you're adding 1, and everything is what? Zeros. Belong to the host. Get it? Very good. Now I'll do the same way here. The network will have 2 networks, right? It will be either 0 or what? Or 1. So the portion here is going to be added with the network ID. Now I would have a 2 network ID added over here. Let's put like example like 3 and 4 from 2. Meaning coming from the network 2, you add another one, and network 2, you add another one. Correct? Right? Or, if you would like to have it in a nice relay, you can have that's coming from network 2, that's still coming from network 2, but you can add that's a first network from the network 2, and that's a second network from network 2. Much better. So what's happening here? I have 0 or 1. So okay, I need to add what? 0 to here. Correct? And what do I need to add here? 1. Correct? So anything else is going to be what? Host. That's because of the network ID. So you're going to have what here? Let's write it down in. So now I was able really to divide my given one, right, to 3 networks. I have the first one, and I have the second one, and the third one. Do you remember amoebas? In the same way. When you have the first one here, it's like what? The amoebas actually, when it's divided for 2 pieces, the old one does not exist anymore. But it already exists within the newer one. So you cannot assign PC for the old one. No. Because it had been what? Divided. The same way here. When you divide it for two pieces, what? The old one here is no longer exist. But it's already included with the newer one. But you cannot assign a PC to the older one. But you have to assign PC over here. So now let's write everything now in a decimal format. So you have that in 192, 168. That what? That what? Then one of what? 128. Correct? The same way here. 192, 168. That one. That what? 1. 92. You have two ones here.
Wait a minute, hold on. You mean for the IP address?
Yeah, no, that's not IP, that's network ID, yes. I already converted that to be a binary. Correct? Now let me write down now the subnet mask. It's gonna be what? 255 in what? In a decimal format. 255 what? What?
192.
192. Very good. The same way here, because it's gonna be the same anyway. 192. Now let's go back to the slash. Slash here now is different. I cannot write down the slash here with the old one. Okay, let's write down here the newer one. It's gonna be what? 192, 168.1.0, right? And 255, 255, 255, right? What? 128. Correct? The same way we have it over here. So now we're gonna write down the slash. If I need to write down in a slash format, I said I need to count how many networks belong to the subnet ones, right? Belong to the network portion. Here we count is what? 24. What about here now? I do have 1 in addition to that. So when you count 8, 16, 24, 25. Very good. So you can have slash 25 here. The same way here. If you want to do it with the old one, you do the same way. So you count 8, 16, 24, 25. Very good. Now with the newer one, how many I have? 8, 16, 24, 25, 26. The same way here. 8, 16, 24, 25, 26.
So you don't count those two as 8, you count those two as 1.
Yes, because it's a binary.
Okay.
I say this portion here is a binary. The other way around, let's put it between bracket and that's your binary. I wrote the last octet in what? In binary system. Very good. So you can do it here also as well. That's your binary, and that's your binary, and that's your binary. Did this help? Very good, right? And that's what we have. That's in binary. Much fair? Common sense? Now, when someone asks you, would you tell me what is the first PC in each of these networks?
First PC is just on the network?
In each network, the first PC.
Well, on that one it's going to be 192.168.1.1.
Very good. What about here? Of course, the old one is what? Is not. You cannot assign PC here, but you can assign to the newer one.
That's going to be 192.168.1.129.
Very good. And here?
192.168.1.193.
Very good. Any questions? Piece of cake? Simple? See you next class. Thank you very much.
All right.